Okay, so have you ever just looked around and wondered if there's a hidden language to everything? You know, some kind of secret code that connects the stars, a galaxy, and even the numbers we use every day? Well, let's dive into a project that's trying to do just that. Decode the whole thing.
It's honestly one of the biggest questions out there, right? Do things follow these strict, predictable rules? Or is all of this, well, just a beautiful random accident? For centuries, that's the debate we've been having.
And this is where it gets really, really interesting. A new research initiative called Project Synthesis is basically saying, hey, what if the biggest secrets aren't in order or chaos, but in the incredible, complex dance between the two?
So how in the world are they pulling this off? Well, the project's big idea is to create a kind of universal language. They're smashing together different fields of math to look for hidden patterns where nobody ever thought to look before.
And the ambition here is just wow. They are not staying in one little box. They're blending the pure abstract world of number theory with the nitty-gritty of information theory. Then they're throwing in complexity theory, which is all about chaotic systems, and even the massive scale of cosmology. It's this wild combination that lets them see things in a totally new light.
All right, so that's the what. Now let's get into the how. The team came up with something you can basically think of as a recipe. A way to cook up brand new mathematical ideas by mixing very specific ingredients, a little bit of order, and a whole lot of randomness.
Here's the core technique. It's brilliant. They take something super orderly and predictable, like the Fibonacci sequence, 1, 1, 2, 3, 5, and so on, and they smash it together with something profoundly chaotic, like the number pi, whose digits just go on forever, with no pattern. And to control how they mix, they use a third piece, a modulator, like a smooth, gentle sine wave to guide the interaction.
So this is the key takeaway, this three-step process. You start with your predictable base, then you inject a dose of pure randomness, and finally, you use a third tool to shape how those first two things play together. It's that exact combination that creates something entirely new and unexpected.
So you have this powerful new recipe. What do you go looking for? Well, you go after the biggest game in town, the greatest unsolved mystery in mathematics, prime numbers. I mean, these are the atoms of arithmetic, the building blocks of all other numbers, but their pattern has stumped the smartest people for thousands of years.
And look, that is not an exaggeration. Understanding primes is like a holy grail for math. If you could crack their code, it would be a monumental achievement. And that is exactly what this project decided to take a shot at. If you've ever looked at a list of prime numbers, you know they get more and more rare the higher you go. They just seem to pop up randomly with no real rhythm or reason. It's this apparent randomness that Project Synthesis wanted to poke at.
And to do that, they actually had to invent some new words. When their recipe created a sequence of numbers with a surprising number of primes all bunched together, they called it a prime oasis. Makes sense, right? And when it created a sequence with way fewer primes than you'd expect, they called that a prime desert.
Okay, so they had the method, they had the target, and they had the new vocabulary. Now for the really cool part. What did they actually find? This is where their recipes started cooking up some truly mind-blowing results.
Get this, they figured out they could actually control where the primes show up. They developed what they call amplification functions, specific recipes that could reliably create those prime oases. And on the flip side, they came up with suppression functions that could just as reliably create prime deserts. They weren't just observing randomness anymore, they were shaping it.
And you can see just how powerful this is. The bar on the left, that's the normal expected number of primes you'd find in a sequence. But on the right, after they apply one of their amplification functions, look at that jump. They could predictably make sequences that were way, way richer in primes than anything found in nature.
But here's the twist. As they kept tinkering with the recipes, they found that not all their ingredients were equal. Certain numbers, when plugged into their formulas, had this bizarrely powerful effect on the whole outcome.
The first of these special numbers was 2, the very first prime. Okay, maybe not a huge shocker, but it consistently created these really stable, patterned results. But the other one was 7. 7. Why 7? Out of all the infinite primes in the universe, why did this specific one have such a huge, stabilizing influence on these incredibly complex new sequences? It was a total surprise.
So here's the deal. When they actually measured the influence and the stability that each prime had as an ingredient, 2 and 7 were just clear outliers. They consistently made sequences with way more structure and stability compared to other single-digit primes like 3 and 5. It's like these two numbers have some kind of special property that we're only just beginning to see.
This whole discovery just blows open a new frontier. We're not just finding new numbers anymore. We're literally creating new maps of the mathematical universe. So let's talk about what that could mean for the future.
And this isn't just a thought experiment. The project has already generated dozens of totally new integer sequences, series of numbers that have never been seen before. And the goal is to get them submitted and officially recognized in the Global Database of Math, the OEIS, so that other mathematicians can jump in and study them too.
And here's one of them now. This sequence was created using that Fibonacci base, the chaotic number pi, and, you guessed it, that special prime number 7. It has a hidden logic to it, a complex pattern that was born from that unique recipe of order and chaos.
And believe me, they are just getting started. The next steps are pretty clear. First, see if bigger primes like 11 or 13 also have this specialness. Second, make their tools even more precise, for finer control. And third, and this is the big one, see if these new mathematical structures can actually model real things in our universe, like how galaxies are distributed. Which brings us right back to that first big idea. Project Synthesis isn't just about finding new numbers. It's about learning to speak, maybe even to write, in the fundamental language of reality itself. It's this amazing reminder that hidden beneath all the noise and chaos, there might just be a deeper, more beautiful order than we ever dare to imagine. And that leaves us with one last, pretty exciting question to think about.